Okay. I'm starting. Normally, it's the basic points. Also, normally servo drivers. You should check to the wiring, and you get MCCB, multi-case circuit breaker, and magnetic contactor or nose filter. You can wire, and then you can connect from here. And for servo motor drivers, you should be careful. It's more important point. Servo motor drivers UVW should be wire, but servo motor cable has a UVW signature and label. You have to put U to U, V to V, W to W. If you mix it, you will get error, and this is important. Also, for the servo motor encoder should be wired to the CN2. Also, for the servo controller part should be wired to the CN1A. And for the other servo driver, you should go from CN1B to the other servo driver, CN1A. For the CN3, you can connect to the servo limit switch also signals to the here CN3, and this is the important point. Also, this is the safety stop set logic input. You have some switch and jumper here and cable, and you have to put here, or you have to add module to here about the which is MRJ3D05. And I'm passing here. Wiring issue, installation issue here, and I want to show to the power connection to you. Also, this is important for a point. For the 200 voltage AC servo drivers, you can do a three-phase wiring. This the servo drivers is MRJ4 10B to MRJ4 350B. You can wire L1, L2, and L3. But some of them, we can use one phase 200 voltage. This area is, these servo drivers are MRJ4 10B to MRJ4 70B. Then you have to, depends on the series, because we have MRJ EB series. Also for those wiring, for MRJ B wiring, we have to check the wiring part of MRJ B instruction manual. For the MRJ4B series, for this servo drivers, you can wire single phase, 200 voltage. L1 to L3. You shouldn't wire to L1 to L2, because when you write wire like this, servo parameters is deleted when you power off and power on. This is the important point. You should check your servo amplifier module, and you should check the wiring power supply wiring models. Because some models you should wire L1 and L2, but some models you should wire L2 and L3. Depends on the model. This is important. Also, servo amplifier has a CN3 connector. You can limit switch. We have addresses. And also, you can check this connector labels from the servo amplifier software MR configurator too. This module inputs depends on the stroke limits and stock signals. And for output issue, you can check the electromagnetic break interlocked and encoder pass information you can get from the CN3 connector. And I'm passing here. I think we can skip here. And this is important. When I go to the customer asks me, maybe you don't use and you can have a problem. We have some jumper and issue this item. And for wiring, inserting to the cable, you have to use this push button open tool. Push down the open tool and release the open tool to fix the wire. This is important point. Please don't lose this item, this tool. Then I'm switching to this module now. And while you are controlling QD77MS16, you can check to the LEDs. And if you don't have run, access, and error, and hardware failure, watchdog timer error, you have. If run is running, the module operates normally. And error LED is LED showing system error. You have system error. And if run is okay, LED is light. This during exist stop, during exist standby. It's not running. And run while run and access LED is lit during access operation. When run is lit and access and error is flicking, the access error occurred. And when run and access and error LEDs lit, hardware failure occurred in your system. And when you have hardware error, please inform us and send your model to the technical service.
Yeah, can I ask you one question?
Yes, you can ask.
Yeah, yes. Actually, before I told you, one of my client is having a 6-axis drive. He's also used the same the motion control module and accessing the 6 drives. Okay.
Yes.
In the drive, he doesn't have any errors, but he's having some issue in the positioning. Like he's having the machine was working since long back. It is working fine. Nowadays, they are facing an error in positioning. Like whenever they are giving like for example, they are giving a parameter for 3 meter. Okay, the machine it was stopping at 3.2, 3.4, 3.5. Like it is varying every time.
When you start, you give the start, isn't it? You are giving the start to the positioning, and you are seeing the error. Is it right?
Yeah. Positioning actually. Yes, you may proceed.
Normally, do you have alarm in your servo driver, or you are seeing this alarm in the just this module?
No, actually there is no alarm. There is no alarm at all. There is no alarm.
There is no error, no alarm.
Yeah, no alarm, but the positioning is varying. Like every time it was not in a exact position.
I think you should check the positioning. Maybe the electronic gear parameters, it's not good for machine. You can check it. But you don't have alarm, but the positioning is wrong. We can check the electronic gear parameters, I think. I will explain you. After this information, I will explain you, because if the servo controller says you should go at this point, and if servo motor and servo driver, because
okay,
from the
and for the safer side, I have checked the backlash of the machine. There is no backlash also.
Maybe you should check the backlash also.
Yes.
Electronic gear parameter.
Yeah, okay.
Because you are saying to servo motor, servo driver to go this point, and you are getting information from the encoder. if the encoder, you cannot, servo driver or PLC didn't get information, the same information from the encoder, servo motor should have an alarm. Because this, I think the system is going, but about the backlash or electronic chair, something happened, then the system, the position is missing. You should check this thing. If you cannot solve the problem, please inform me. We can work together about this issue. Okay?
Yeah, sure.
Because if the encoder should give us the same positioning, if the encoder does not give those positioning, the pulses, the system should have an error. And this is the main point also. When you energize the servo amplifier, you will see the A-axis status display. B-axis, for A-axis, you should see B01. And for the B-axis second station, you will see B02. And B indicates it's ready off, servo off status. After ready on signal, but servo off signal, you will see C indication in servo amplifier. Then when you see D indication here, this shows us servo is ready to control, and when servo on, we can control the servo amplifier to the positioning. While we are controlling the system, it should be D positioning. Servo amplifier should be in D. Also, while you are checking the alarms, first you should check the access point. These servo amplifiers N01 and N02, W2, we have some MRJ4 W2 servo drivers, and you will see after N01, when you are seeing these alarms 32.2, you can check from the manuals, the troubleshooting manuals. Also, you can see from the softwares which troubleshooting meaning. Also, if you see the N02, you should check second axis servo drivers, and you should check, and you can control. You have to solve the problem for second amplifier. I'm skipping this. How you can open the software? First, I'm opening the GXWorks 2. I'm opening GXWorks 2 because the PLC is Q series. I'm opening Q series PLC Q03 QDE and simple motion project ladder. I'm opening. Then we have to do intelligent function module. We have to right click to here and add new module. We have to enter the mounted slot node and specify addresses. And I'm doing right click, new module, and simple motion module setting. And this is which module do you use? You have to set here. I'm writing to QD77MS2, and mounted slot node should be entered. I'm selecting 0, and address starts with 0. I'm entering OK, and then you can see here simple motion module setting. It's opening. I'm pulling here. Also, when you start the making the project, also you have to enter the IO assignments. But I won't write the project to the PLC. Then I'm skipping here. Then you are writing the CPU mode.
Excuse me.
Yes.
Yeah, yes. Can I leave now and I'll try to join after some time? Please share me this presentation
Okay.
in the mail.
Oh, of course. I can share with you. I hope what I explained, it will be worth for you.
Yeah. Wait. I'll do one thing. I'll make an video recording of your training things. So once I will be free, I can able to see every details in the video, right? Now
Okay,
you started.
No problem. No problem.
Please give me a moment.
Okay.
I will prepare the things. Like, can you please start this presentation, like programming presentation, from the beginning?
Yes, you can. Also, I will share all of it. You can send to the because manual. Also, e-learnings I will explain, and you can send your friends or colleagues. No problem for me.
Yeah.
Okay.
Please a moment.
When you say okay, I will continue. I'm ready to go. Okay. Then you are writing to the PC to USB to PLC, and normally you have to communicate with the PLC with connection destination parts. You know this because you are using PLCs. This is the main point. While you are writing to the intelligent function modules, you have to select the intelligent modules. For detailed parts, you have to click the intelligent module part to the right intelligent function modules parameters to the PLC. But I cannot see from here, but in your system, you will face with the intelligent function module target, and you should click on here. And here. For the setting, now we opened it. We are adding module, simple motion module setting tool. Normally we set in the GXWorks through QD77 MS2, and I am writing here, and the module start address is 0. I'm writing okay. You can see normally we select 2-axis servo module, simple motion module, and we can show here 2-axis, and we can see because of normally which device which servo drivers we will use, we have to select here. Now maybe we can use here, we can use MRJ-EB or MRJ-4B series, or maybe third-party Nikidenso or some of a step-oriented model we can use. Now I'm selecting MRJ-4B series. Okay. Then I can select also MRJ-4B to here, or maybe I can select MRJ-EB here. Then, after selecting here, I can check parameters. And servo system parameter about the simple motion, you can see from here. From here, you can check which system can be controlled with millimeter or inch or pulse. You can check from your system here, and you can set your about your machine configuration. Maybe if you use the reduction ratio, you have to write from here system. Maybe you are using the electronic shear and you have to set from here. And this calculation, when we put to compute basic parameters, all system can be calculated from here. Do you have a question? Normally, I'm selecting maybe both script or backend opinion. You have to write to the DP part and NL and M part to the here. And depends on your system, you can calculate your system parameters, and calculation part is coming directly to the here. And this is the number of pulses per rotation. And this part is moment amount per rotation. And this is the unit magnification. And this is the bias speed at start. You can change it. Depends on your system, 0 to 200. Also for your speed limits. Every system has a speed limit, and you can set your speed value to here. And for the acceleration time and deceleration time, depend on the speed limit value, you can write parameters to here. Maybe your question about the backlash compensation amount. If you have a backlash in your system, you can add here. How you can do it? You can select and maybe write and some part of the motor, or you can put, or maybe in your machine. Please give 100 million pulses, and when you turn to the system, please move to your system. Then turn it to the reverse side. And please check there's the system is going to the right starting point or not. If it's not going to your starting point, you have a backlash in your system. And then calculate here, right here, and try again in your system. Is it okay? Jangir? I hope it's okay. Also, after you calculate the backlash and you can try to the backlash positioning, you can enter to here, okay? Also, software stroke limits, or you can enter some wired stroke limits about for wiring with sensors. But depends on the system. Maybe you can add software stroke limit, upper limit, and lower limit. This depends the more complete. You can make the system more safety, and you can add here from the software stroke limit, lower limit, and upper limit. You can add stroke limit to here. Also, you can invalid or valid to the system about your software stroke limit system from here. And system, while you are giving to the system, my position is okay, I came to my position. You can say when the limit beats here, when you are saying my positions come here, my position signal should be come here. But if you want them beforehand from this position, you can enter to the inch level. Because if I select the millimeter, it will change here in position. When I change to the unit setting to the millimeter, the command in position width change to the micrometer. If you say to the before the 10 micrometer, I want to get the position command in position flag, you can select from here. You can adjust from here. Also, you can check torque limits, setting values, and you can torque limits setting to the 1 to 1000. You can check from here. Also, you can check speed changing procedure can be changed. Also, more important functions could be select from the here. If you in first while you are using the first time, you can have some error because system should get stop external command signal. Maybe system can get. Also for stop, you have to stop the if you don't use the first stop selection to the signal to here, you have to invalid because if you don't write to the invalid, the system will ask the first stop signal. Because of that, you have to set this. If you don't write this first stop information signal to here, you have to set invalid to the here. And you have, if you want to more acceleration time and deceleration time, we have 3 more parameters you can set from to here. And for the jog operation, you can set jog speed limit value to here and acceleration, deceleration to here. For the rapid stop operation, you can select from here. Also for home positioning, you have to set from here. You should home position is your system about the which area is your 0 starting point. Because of that, we have to enter here. We have how many proximity dock method, count method 2 method, and data set point and scale home position signal detection method. We can check. We should select depends on your mission. Because system, if you select the proximity dock method, you are saying when I'm saying go home position. Then after we are entering the signal to the servo drivers or the QD77MS module, when we see the proximity dock signal, it starts to do creep speed here. Creep speed is entering from here. Then after we release the proximity dock sensor, the system mission is stopped. Then it starts again with creep speed. And encoder, we have an encoder in servo motor. When the encoder 0 point is seen, the home position is accessed, and this is my 0 point home positioning. When the position proximity dock method, maybe count method, we select the count method. This working style is different. You are saying the start home positioning, go your home, and introduce, and you are with HPR speed. You are going to the machine, and you are seeing the dock signal, proximity dock signal in the system, and you are entering to the movement amount after proximity dock on from the here. Detail from here. When you enter here, it will goes like this. Then after that, when it goes this to here positioning amount, and it goes slow stop, then it starts to work again. And when the system, the servo encoder, goes to 0 signal, and home position will be done. And when we check it, count method 2, you cannot see the 0 encoder 0 passes, and it sees the dock signal, then it goes with the setting moment amount after proximity dock on. Then when it goes like this amount, this area is the machine home position. And the data set point, you are saying the buffer memory, and you are giving to the some point. Maybe you can add just some input, and when that input is on, that point is the machine home positioning point. And the scale home position, it's different. Some machines want to this one, and when you are start the home positioning with creep speed, it goes and proximity dock seen. After that, speed is 0, goes to 0. Then it returns to the work again, and system is going to the 0 signal, and it stops again. With creep speed, it starts to work again. Then when it's see the 0 point again, the home position machine will make it. And you can select home position direction here. Also, maybe you don't want the machine 0 points. Maybe you can add my 60 micrometer is my 0 point if you want to want to this, and you can add here, and you can write to the home position speed to here, and retry if your system is not working. If you don't want to retry function system, you can switch do not retry. You should make this positioning. Oops. If you don't want the system home positioning, you can select retry HPR with limit switch. You can select it. No, sorry. This is wrong information. If you don't want to the system HPR positioning, you should select home position control is executed. And if you select this one, you don't need to write to the make to the home positioning. Till now, everything is okay, or do you want to ask a question? Also for this area, you can see SSCnet 3 hash. If you want to use MRJ3, this system use SSCnet 3. When you select this one, oops. Also, I want to show here. You can just use MRJ3. It's here. If you want the SSCnet 3 hash, you can select here, and you can select SSCnet 3 hash. Okay. And you can select MRJ4. Or maybe you can select here MRJ-EB. I'm checking the parameters. Okay. Here, I want to come back. For the setting data, for control issue, parameters can be shown like PR, positioning parameter, home positioning, and servo parameters. And for positioning data, you will see positioning data area, DA, and synchron control parameters we can see here. And control data can be seen in the some buffer addresses. Control data shows with CD. X control data can be seen CD, and synchronous control can be controlled with the CD. And monitor control data shown with MIDI. Monitor data, yeah. Which I explained to you. It's shown here. Also, we can check with servo amplifier parameters. Servo amplifiers come from here. Servo amplifier. It's opening. What's happening? Why it didn't open? Yes, it's open. Several parameters you can control from here. Also, I want to show here basic parameter. Basic parameter, when you start the first controlling and setup, you have to write here. If you don't write, you have to control here. Normally, the system comes with the enable force stop input. You can control from here rotation direction and force stop selection here. While you are first controlling, please do disable setting or please wire servo amplifier to the force stop signal. Otherwise, you will get E61 error. And the direction of the servo drivers can be controlled with rotation from here. If you select clockwise, the rotation will be clockwise. If you select the counterclockwise, the opposite side of the clockwise, the system will work. Servo stop selection is turn this option on to enable to use the force stop input EM2 and EM1 signal. If you don't give the signals, the system will get error. And if you don't use it, please make disable your system to here and write existing system from here. Then please turn off and turn on the system, because while you are controlling to the system, you will see star here. This star parameters you have to write to the servo amplifier. Then you have to power off and power on. If you don't do this, the system won't understand your settings. Then it won't work. And I explained parameter setting to you. And also electronic gear. Do you have a problem from here? But I explained to you. I can explain again to you. It's okay? Sorry? It's okay. Okay. And shock speed I explained to you. Also, I've sent this data to you. Also, I want to explain again. If you don't use lower and upper limit switch, please change it, because normal system gives once 24 voltage. And if you don't give this 24 voltage, you will have a upper lower limit error, and system should be also stop signal should be controlled. If you give 24 voltage to the system, this system will stop. Also, you have to select the external input signal selection. You can give the lower and upper limit to the servo amplifier or QD77 MS signal to module, and you should select from the PR parameter 18. You have to select from here which QD77 MS or servo amplifier. You have to select it. So, also after selecting all parameters, you have to write your module from by PLC parameters. PLC. Then the system should be power on and power off and power on. Then all parameters will write to the servo amplifier. Also for all system, also you have, after writing to the PLC, you have to servo amplifier power off, also your system off. Then together, all system should be power on. Okay. For the before the programming, could we have a break, maybe 5-10 minutes? is it okay for you? Okay. I'll take some water and I will come back. Okay. Okay. Then also I prepare some documents, but sample projects, and I will show how to use it. And I think if you understand the buffer memories, no problem for you, but for the U, E, and G part is, I think, when I am learning, I have difficulties with this understanding. If you understand this one, simple motion model is really easy to use, but also it depends on the machine. If machine is too hard to work and make the system is algorithm is hard and difficult, also writing process would be more difficult. Positioning. Okay, we are writing to the PLC, but we are writing to the PLC with to parameters and the simple motion buffer memories. Because every data and signal outputs and the parameters which we enters, it is in, we have to write to the simple motion module to here. And also the buffer memory areas should control to be seen from the help menu. You are entering help and buffer memory address list. It's opening. Normally, this is the you cannot know the buffer memories of the modules, and you have to check to this Excel. And this is the buffer memory addresses is changing depend on the access, and you have to control it. For the Excel direction is here, and the buffer memory address. You can also, I showed the first section, the parameters have to change, but if you don't want to use the software parameter change, you can change from the buffer addresses. Every parameter has one buffer addresses, and you have to control it. Sorry?
Yeah, it will take time. No, we have to be do the fabrication is done here. Yeah, then it will take.
I don't understand. I don't understand. Sorry. Yes, maybe. Maybe.
Because the fabrication will take time. It means we have to be wait.
Okay. Here method. Now for the parameters and also for monitor data, if you want to monitor which was the servo monitor, which it is, and or for the speed control, you can check and you can monitor the buffer memory addresses. For the control issue, you can set the servo motor. You can go there, or your speed is here, home position parameter is here, and you can change the speed control to the position control or synchronization control. You have all of this, you can control with the buffer addresses. And this, you can see here, UN and G and the value. And this one is N and shows head of I/O number of the simple motion module. And we set, you can check from the here we can see 0. This is my system, but you if you have a 20 here, you have to write here to 20. Or for G, this one is the buffer memory address. You have to write here. While you are writing the project, PLC, and you are saying the input output and for buffer memory, you have to check. And then you are writing with move command, you are writing the buffer memory addresses. When we check this here, U0, and yes, we have U0 and G1050. I'm checking which one. This is the input output parameters buffer addresses, and this is the simple motion monitor addresses, and this one is my control data area. I'm checking this one is start G150 QD77MS and the other modules if you use them. You get to start which address, which module, where I should start. I can implement to here. I can write here. And this is the main point of the programming. From here, we will write all buffer memories, what we will use. Buffer memories we will write, and we will give input output to signal to the system. And normally, for when we have to write to the PLC, then PLC should give PLC ready signal to simple motion module. Then, if the simple motion module gives to the PLC QD77 module is ready to control, and we can say to from PLC all access servo on. If we can give the servo on status here, the simple motion module will give the servo amplifier servo on command, and servo motor will be all of them will be servo on. Then servo amplifier will give to the simple motion module servo on status. Then this module, simple motion module status, give information to the PLC. Also, I'm writing to you can write like this. This is the off for one scan only after run, and you can write this is the initial storage bit. Parameter initialization command storage and flash ROM write command storage, and if PLC ready on, and give PLC ready signal to the simple motion module. Let's check here. IO signal. We are checking from this Excel sheet, and this is the IO information. And when we check it PLC ready signal, we can see Y0 to PLC ready signal. If PLC ready is okay, also QD77 is ready, we can check from here again, X0, if the module, also simple motion module, is ready. If synchronization flag, if servo amplifier and servo motor, servo amplifier and servo simple motion module is synchronized, system is synchronized, X1, we can give the servo amplifiers all access servo on. We can check from here. All access servo on. Also, okay, this is for, we gave example for 0 to 0. If our system works start with the 20, we can write here. All input and output signals is changed. If your starting address is 20, you have to use Y20 and X20. I'm giving 0 again. The macro is working on it, and I'm saying like this. It's clear here, because it's the important point. how to check and how to read the input-output addresses. I can forward it, but you can find. I find from here. And I can forward, no problem. But you can find from here simple motion module setting tool, and you are coming to help and buffer memory address list. The Excel is opening. It's opening. You can find from because it's collecting is harder. I think you can check, and software has this Excel. If you have an Excel sheet software in your PC, it's opening. It's coming with the tool. And I'm checking. Also for the joke information. Joke operation is a function used to manually operate a servo motor in the forward and reverse run direction at a constant speed. Normally, you are giving the speed information to the system, and then you are giving the forward information. Let's check CD and control data. CD, we are controlling CD on control data. Speed information. I'm coming to here. Shock speed. Where it is. I couldn't find the shock speed here. This is the double word. This is word. It's 2 words, double word. You have to write here to do with D move. And you have to write GD 1518. I'm coming here. 1518. And to use the second axis, you have to come here and you have to select axis 2, and you have to write the 1618. And then you are writing with move command. You are writing to here with move command. Then maybe I can show you from the here. I think we have a shock speed. You have to use the move command here. And you are writing your shock speed, enter to D0, and you are moving and copying to this model, this buffer addresses. And for second axis, you are writing again with the move. Then you have to give start information. How we can find? We can find from the input side. Let's check. Axis 1, forward run shock start, Y8. For reverse start, Y9. And you are giving this information. For the second, or maybe for third axis, you are checking. Here, third axis, you have to give YC and YD. And from the here, also I can show you, oops, not here, we can check shock speed Y8 and Y9. Be clear, if the speed is 0, you shouldn't write to the, you shouldn't give the shock start. If you give your speed is 0 while you are doing this, you give start, you will get an error. Because of that, be careful of this. You have to add, if your speed is bigger than 0, give start. And this is where the start forward and reverse one. Also, you can, I'm checking from the here. I explained you to the home positioning. For home positioning issue, you have to write to 9001 to the positioning address. The machine operation starts after the OPR parameters are set and positioning start now is set to 9001 and the OPR designation which turns on the position start signal. We are position start addresses. We are controlling from the CD part. I'm giving to here. You should start with the home positioning for the setup, and you have to give, if you use first access, you have to use G10500, and you have to move 9001 to this buffer addresses. Then you have to give positional start addresses. And we are looking at the IO addresses. The start addresses is position start address for first access Y10. After you give this information, we set the parameters like here, proximity doc method. The system starts to work, starts to find its home position. And after the system gives the signal, also you can check from the module monitor system from here. Maybe, I don't know, it will open or not. I hope it will open because I'm not connected to the PLCs, QD77MS. But you can check from the monitor sites, and if it's the home position is okay, the system is in 0 position. Yes, you can. From the while you are controlling this home position, you can select monitor item and home positioning. HPR movement, but no, I'm controlling HPR. Also, maybe if you want the jog speed control, you can add here. Or servo off command, you can control monitor your system for the HPR positioning. HPR flag off. HPR request flag and HPR complete flag, HBR. Normally, when you are online, this HPR complete flag, if you make the home position, your HPR home position complete flag will be on, and you will check all your status from here, and also you can use the bits from here. You can check. And it comes. Normally, for initial setting, you cannot see from the home positioning, home complete flag signals to here. But you can add from the select monitor item, and you can check, and you can add from the forward jog start or position complete or busy signals. You can add to this monitor, and you can check from this monitor all of these issues from the access monitor area. And be aware of for this application, for this function, you should be online start monitoring should be on. Also for this area, If when you get error, please look at here. Also, you have some backlash or some positioning errors. Please check here, and some errors will be seen like red or maybe blue items. Please click here, and you will get more detailed troubleshooting information. And when we connect it to your system, we are checking to here. Before asking to us, you can also check from here, and you can maybe emergency stop information or absolute position composition error. You can get information, troubleshooting information from this area. Where I came to here, access monitor information. I came to here. It's slow because I'm not connected to the PLC. But in the system, when you are online, there won't be a problem. It suddenly will come up. Also, till now, do you have problem? Okay. For others, and continue. For the system, you can do position control. You can do a linear control or 2-axis circular interpolation control, or speed control, speed position switch control. For while you are doing linear control, you are giving the points for 2-axis linear control. You are giving X and Y positioning addresses, and you are giving speed. And the system goes with same this position to this position. And 2-axis circular interpolation position, you are giving this system control is performed from the start point address from here, current stop position, to the target position using 2-axis X and Y system. There are two kinds of circular interpolation used, one based on the subposition, subpoint. The other one is you are giving the center point to here, and it gives the shortcuts and right or left cut, and this position goes to the end position. Depends on your subpoint or center point, and clockwise or CCV type. For speed control system, you are giving the speed, and you are giving the start position, and the system till your stop command, the system will go, and when you give stop commands, and it stops. Also, you can use speed and position switching control. Position start with the speed control. Then your buffer addresses, when you select, give it this, maybe 1 on the bit. The system will start to do control by the position control, and this you have to give the information about the how much the amount moment amount, and after this moment amount is completed, the position will stop. Also, you can use this positioning with absolute system and increment system. Absolute system, ABC, is this method specifies the original position and standard position. Absolute address depends on the 0 point. You are giving the home, you should do 0 home positioning, and you should give the position. Please go 100,000 millimeter, and it specifies the 0 point and goes to 100,000 positioning. For increment positioning, it's not depend on the home positioning. It's the method specifies the movement amount and movement distance using the current stop position as a start point. I'm 1,000 millimeter. Then when the system gives the 1,000 and 2,000, I will go to the 8,000, but for the zero positioning, my position should be 2,000. I have to identify this position to the parameters. We can check from the here, and for the software, I'm checking positioning data, access to data, and you can write to here. Also, I prepare some positioning. Yes, here. You have some section from the position data, axis 1 and axis 2. Oops. Axis 1. You can select from the here end position and continuous and location, or you can check from the here absolute position, linear position, or incremental linear position, or fits position. You are giving just position, and once you explain, the system will work with fit position. Or with the speed position switch control, you can reverse or forward control. This with if F positioning, forward positioning, and R reverse positioning. Also position speed switching or two-axis linear interpolation or two-axis fixed fit control, you can select from the here. Maybe circular interpolation can be selected from here. Also, two-axis speed control or forward or reverse can be selected here. Also, for the acceleration, the acceleration time should be selected from here, which we entered from the parameters. Also, command speed should return to the here. Also, I want to explain to here ends and continuous part. Let's check here. Start positioning. You have to, while you are working absolute position, you have to select if you just control this line, you have to write ends, absolute position, acceleration, acceleration, and position address and command speed. You are saying your starting address from this axis, this is the one axis, start from the first table, and you are sending one to this buffer area where we are finding command control data, position start address from the here G1500. We are sending one to control the first table. Then to start this address, we are giving start signal where we find start address here, axis 1 position start address. We are giving Y10 to here. And we are giving, we give this command to do with M6. After this command is accessed and worked, we have to reset this signal. Also, we are giving here, we give 3000 command speed and position address with here. And we are giving start position, and it goes with 3000 millimeter with speed. And while it's working, the buzzer signal is on. When the system is complete, position complete, X14 signal is coming to the PLC. Also, we can check from the here X14 signal axis 1 position complete signal is on. This is the important point. We used and here. And we are saying position of the next position data no is not executed. We are saying the system, if we use and, we are saying we will please do first table work with this one, and after this one is worked, the second table won't work. It will wait start positioning again. If we select continuous mode, continuous mode. After position is completed, the machine is stopped temporarily, and then position of the next position data no is executed. Let's check. We are giving the continuous. We are giving command address and speed. It commands speed and command address. We are going. Then it stops. Then it starts the second table, and which is given B position is given, and A speed is with A speed. I'm going to the B positioning. If we select location, this one is after positioning is completed, position of the next position data is executed without the machine being decelerated or stopped. Continuous path. If we select here, location, this one, we don't need to stop like this. It starts, it works like the same issue. It goes to A position, then it starts to the position B, and with A speed. But for this issue, with continuous and path, in the second or the third, if you can write like this continuous steps, I can start with the continuous. We can feel the positioning from here, position datas, like here. But at the end of it, maybe you can check we can make the location. Also, you have to give the speed information, but at the end of it, you have to select the end, because end you have to enter position again. After fill this one is continuous and location part, you have to give the end positioning. Then this positioning will work. Then after this addresses is operated, the system will stop. Like if we are using the pet operation with different command speed, we will give the pet operation start, and we will go to the command address A. Then with different speed, we are going to the B speed, and then I will go to the B addresses. And this operation pattern is end. Then I'm stopping and I'm waiting the start information, position start information signal again. For interpolation control, system 2 or 4 motors should be controlled. 2, 3, or 4 motor in some ends. We should set to linear interpolation or circular interpolation control. There are 3 types, and this circular interpolation, the type of the use being set in the control system for the position data. One of the axes set the control system is referred to as the reference axis, and the other as the interpolated axis. The simple motion module performs control of the reference axis following the position dataset for the reference axis, with the interpolation axis being controlled along a linear or circular path response. For this information, normally we are giving this x1 and y1, and we are giving information x2 and y2. Then we are giving the basis axis to speed information, and we are giving the base axis to start information. For the two-axis circular interpolation control, okay, we are giving the command addresses to them, and we have to give the information where it will go. From here, from another point, or from here, I have to give the where they will go. Maybe you can give the center position information, and depends on the center position, it will go here or it will go from the here. But it should be calculated exactly, otherwise the system will get error. Let's check. Till now, do you have problem, or do you want another information, or if you don't have any misunderstanding, please let me know. Okay. I'm continuing. For start of interpolation, we have to give the same with the start information, and which axis it will work, we have to write here. Then we have to give start positioning again, but we have to fill the table like this: absolute linear 2, or maybe incremental linear 2. When you select axis 1 with this, the other axis here, I'm selecting this one, and absolute linear 2, I'm giving the command speed. When we check to the other axis, you can see yellow line, because this one, axis 1, table 3, is the master station. This is the slave information. But you have to enter the position to here. I'm coming to here, and I'm giving information to address, command speed, and acceleration deceleration time. And you have to, we used 2 axes in our system. If you have another axis, maybe 3 axes or 4 axes, you have to select the interpolated address to here, and you have to give start information to here, to main axis 1500, and you have to give start here. Then it will work together, and it will make interpolation system. Like here. The same time, you are giving the starts. You are giving start signal. They will start the work together, and they same time they will go their positioning. And the system, the second system, normally when we checked here, we didn't give any speed information to second axis. We gave speed information to the first axis, and we give information to start information to here. The second axis calculate their speeds depends on the first axis, and it works together, and it starts together, starts to work together, and stops it together. And I explained you, but we can check again from here. This is the main point, axis monitor system. We are if servo system has error and position data or warning or the machine feeds current feed value or all system can be controlled from here. Also, if your position is completed, you will see position completed information to here. If you have alarm in your system, servo position and it will be red in your system. While they are positioned, you can see from here, system waiting and system in interpolation, position control system, or for the interpolated which axon is controlling, and you can see from all data from here. But for the sectron control, till now everything is okay. Do you understand Alzheimer, Alphard, and Tarek? Everything is okay? If you want, I can explain you with the parameter modules point table again. If you used firstly, and it's difficult to understand, but after using and checking, everything will be okay, clear. Okay. For synchronization control, we are using this synchronization control because system we are several advantages to use the synchronous control, some of which are given below. Improved productivity and safe control. Normally, as there is no standby time between operation as which sequential operation, takt time can be shortened and improving productivity. For also, as slave shafts are all synchronized to the main shaft and stopped, then the main shaft is stopped, the risk of damage to the equipment reduced. For synchronization, normally you don't need the mechanical synchronous control. We have in this module synchronous control with the simple motion module, and you have to select the parameters: electronic gear, clutch, and speed change, gear, composite gear, and synchronous control information and COM data from the system with parameters. And you don't need to, you can select and write to the COM information to the servo parameters. Then you don't need to the mechanical COM information. System, you can, from the CAM data list, you can write and select your COM information from here, like here. And you can select what you want to here. It's hard to write everything. You can write your COM data here. And the system, when synchronization and COM information is activated, your system will work with this pattern. Also, for COM information, synchronization control, you should select the main shaft information to hear about the where command generation access or synchronous encoder if you control with the encoder from external encoder. You have to write synchronous encoder information, and depends on your system and electronic gear information or main clutch information will you use or not. Your system should be used, or for the main shaft gear you have to enter and with your system electronic gear information you can select and you can control it. Also with control COM access control, you have to select the COM information, which COM data should be used. You have to control and write which COM will be involved to here. I'm not exactly explaining the synchronous control a lot because this is the basic information. For this step, I want to explain the basic information. When you use the synchronous parameter and synchronous control, I will explain you later again this information. I think it's enough for today. I want to get questions from you. Then we can talk and we can check together with you. I think this is better. It will be better for you. Hi, can you hear me? Normally we can check together. Maybe I can connect to you. We can check together. But for virtual exam or synchronous control, I think it's for today. I think it's enough. For later, when you will use it, we can check synchronous control. But do you have any question or not understanding point? Okay. Here's John Gare. What about you? I think I'm finishing. I hope you will get information and you like it, the training. If you have any question, don't hesitate to ask. Also, I've sent this document and sample projects to you. And if you please check and try to understand. If you have any questions, please let me know. Okay? Yes. This is just the four main startup because I want to give the which meaning of the buffer memory addresses are, how to use the simple motion module software. Because if we understand more, explain more, maybe it will be mixed. After learning this issue, we can explain further information. Okay. Thank you, listen to me. Thank you. See you.